Yeah, so while the last people are coming in, we already have a small Menti prepared for you guys to kind of get to know you also where you stand. So if you take out your phone and quickly scan the QR code that you see, this will lead you to a survey. I also pull this up over here. No, this is to save us some time. So I pull it up. Okay, so let's see who is in the audience here. So we have a lot of red, I can see. Tech savvy but not expert. New to robotics is the majority. Henrique, who were you?
I think I'm the deep tech and robotics expert, but I might have overstated. Depends how good this presentation goes. I might drop down.
It's always a matter of perspective. Okay. So this will be quite helpful. So then what we do is we explain this a bit high level to you, where we are coming from. And then at the end, we will also have much more technical insights, but we also introduce them quite well then. So in case you're not yet a VDA 50/50 expert, then not a problem. Okay, so new to robotics is actually the majority.
Which is good. We might convince some people to join us.
Yeah. Let's see how it goes. And yeah.
We want to move to the presentation?
Yeah, sure. Let's move to the presentation. Maybe a quick introduction firstly. Who are you talking to? So maybe you can see it also here on the sweater. Best robot dad ever. This is our team sweater. Actually, when I was wearing it the first time, the people in the office were laughing a bit because like we do our best to treat our robots well, but they are not always working as they should. So maybe that's a very dad experience. And so we are part of the innovation department in Accenture. So what we do is we build up new robotic business for Accenture. So we look into new technologies that are coming up, where we think or where we see traction from the market or where we see a lot of research, and then we see something that we could incubate, meaning grow within Accenture and bring to our clients that we already work with as value. And so within that, I take care of the Nvidia robotics practice and everything around simulation. And I have Henrique also here, my colleague.
Yeah, exactly. And just complementing what Elias just said, we look at technologies that are like, I would say, 2 to 5 years away from maturity. So there's R&D, which is research and development. There's our things that are going to be big in the future. And we take things that are growing that might be big in 2 years. So it's a tighter deadline than pure R&D. So I'm Henrique. This photo is from last year. So we also presented last year on the topic of simulation. And yeah, we work together. I mostly take care of the topics around systems and platforms, so everything around robotic integration with fleet management systems, operation management systems, enterprise platforms. So whenever a robot needs a connection to something from an elevator to an SAP system, I tend to be a contact point there and like to keep informed about all of those technologies.
Mm-hmm. And so the topic for today is around Nvidia robotics, hyper-reality, and maybe to quickly introduce why is robotics quite interesting and why are we working in robotics right now. And so there are several answers to it, but if you look at the stack, for example on the hardware level, you can see that robotic hardware is becoming much cheaper than it was before. So to give an example with humanoids, these new human-like robots, 10 years ago, NASA sold them, I think, for around 1.2 million per piece. Like they were really expensive. And now they get down to like 30K per robot. So I mean, the kind of tech that's built in there is a bit different. But you can really see that the cost of the robots are going down. And There's a few reasons why this is, with the scale and so on. But that's one reason that's coming together. Then on the software side, we see a lot of standardization of software. So there used to be every company having their own approach for having software, and there are now open source tools which are being adopted much further. And that kind of helps to pull in already existing research into your stack. So on a software platform base, there is a consolidation. And then the huge thing for us is also AI, where we see a lot of shift. And so I separated it out here in level 2 and level 1 AI. So level 2 reasoning is like this long, I think the difference is the inference time. So the inference meaning from the time you give an input to an AI to getting an output to AI. For like level 2 reasoning, it takes a bit longer. For example, for ChatGPT or some like large Gen AI model, it takes longer to get an inference time, but you get also very intelligent answer. And then there's level 1 reasoning, which is, for example, computer vision, which is running on the robot. So it's very fast. And so, I mean, on the Gen AI space, I think you all have seen the advancements there. And also in the computer vision space and all this embedded AI, there's also a lot of progress that we see. And this is enabling quite a bit of use cases that haven't been there before. And then also quickly, services, there are a few models appearing that is making robotics more affordable for many companies. And so if from this growing, robotics is a growing field, to one of the very large players in this area, which is Nvidia. Large player also in terms of invest, like what they take on a lot of work in the ecosystem and create a lot of value. And that is because, so here we have the CEO, and he has the vision that someday almost all things will be autonomous. And it's more a matter of time. And on this, let's say, long-term vision, Nvidia is executing. And that you can see also in the spending. So Nvidia is investing quite a bit of money in the robotics field of their budget, because they want to develop this market for clients. And this future is heavily building on their accelerated computing stack. So it's also a different kind of compute that's then built into the robots. But this new compute is also enabling quite a bit of new use cases that you couldn't do. Like, for example, having embedded AI models and so on is becoming possible with the stack. And so diving a bit deeper into what they're doing, there's a ton of things that's happening in the space. So it's like 70 and more tools that Nvidia is actively developing, or components. And they range extremely far. I mean, some is like embedding ARM chips or getting ARM chips connected with your PC, and some is Isaac Sim. So it's a really large range. They fall into 3 categories broadly. So you can say there's a lot of AI, also simulation digital twins, and then also hardware and hardware-related tools. And so to introduce a few of the main ones you have to know, it's the manipulation. So intelligent manipulation is a super interesting field, because right now, most robotic manipulation isn't very intelligent. It's very repetitive, and that's the strength where you use them. But there's a lot of potential of using AI. Then perception. So you can see, for example, self-driving cars. Self-driving cars can do autonomously much more than many of the robots. So like in this field is much more advanced than the robotics field, and Nvidia is actively pushing to bring the intelligence that was created there to the robots as well. And then on the simulation space, one example would be Replicator, for example. And the idea is here to train, so we have a simulation which is extremely realistic, and that you can use to train your computer vision agents. And so that's a toolkit for this. So it's a lot of different tools, what we want to say. And here, and Isaac Sim is also one that you have to know, because that one we're going to talk of in a second. It's basically the industrial digital twin they try to build. And we introduce some use cases around this in a second, what this actually means. But we just try to set the stage on what's happening in the backend. So it's not actually one thing, it's a consolidation of different tools that all push into this new direction. And so what I mentioned before, what we look at is firstly, okay, what's happening on the tech side, and we also look at what's happening on the market. And we can see that many of the large, so this is taken from an automotive deck, and where we can see like many of these very large automotive companies are having massive projects in the space, where they create digital twins to, for example, build their factory already in the digital world, or where they use the hardware, so they embed accelerated compute, like what would be a good example? What they use? They use, for example, Jetsons, Tesla, in their robots that they can run a lot of AI models on their car locally. And so that's a huge shift to maybe 5 years ago. And with that, it now gets interesting, at least for the techies, because now what we try to show is these are examples where we have problems that we have with clients, and where we see that Nvidia technology can help us address these problems. And so we picked out 3 examples. The first one is the 6D pose estimation one. I do then the modular robot integration. This is very interesting what Henrique represents. And then we talk about connecting different simulators. That will be the last one. And so diving into the first problem, or the first opportunity, or as a matter of perspective. So the problem that we have when you have a robot arm, and the robot arm needs to grab a bottle like this, it needs to know where the object is in space exactly. And if it's off, because this you can grip here quite well, but here if you have a gripper like this, it's really tough. And so there is not much space to mess up, and so it has to localize this object exactly. And right now, how this is done is you have these extremely expensive 3D cameras. So I heard an example of a company, they pay more than 100K per camera. That includes the software in this case as well. And so it's extremely expensive to only localize one object with a camera. And the problem is the hardware. And so the idea here is, let's basically use very simple hardware, like the IntelliSense cameras, which we put here on the slides, and then do all the heavy lifting on the software side. And so there's extremely much processing going on the software side in AI to do this. And then you can see an example here then on the left, on the right, how this is actually working. So then you can see there is this 3D box around the object that's always following it. And then you know exactly where the box is in space, and you can then grip the box accordingly. So it's one short problem, but it's one, if for each tracking you have so many expenses, your robotic solution becomes extremely expensive, and then it maybe doesn't make sense. And by having this on the software side, this becomes much more cheap. And so here you can see different examples, and this is not as trivial as you think. So like for some kind of objects, this works well, but if you have, for example, very intense lighting conditions, or if you have objects like glass objects, like this one would be actually quite tricky. For the AI, there are not too many features that they can detect. And so it's not a trivial problem, that's why it's not solved. But there's a lot of research in this area, and that's what you can then see here at the bottom right. This is actually in our office, where we then test also in-house what kind of objects can we do, what can we promise to clients reliably, and also where do we see still some needs that some research needs to be done. And then we also offer consulting services, of course, where we then have these insights for clients. So this is just one example in the AI space where new solutions are becoming possible. And then we have the modular robot integration. Henrique, handing over to you.
Yeah. So one of the key aspects that I think Elias mentioned before from Nvidia Omniverse is the capability to connect with other platforms. In itself, Omniverse is a collaborative environment for people to work together. And they also provide a lot of support for different kinds of plugins and connectors to other systems. And one thing that we've identified when looking at where along the robotics life cycle Nvidia Omniverse and specifically ISISIM, which is a robotic simulator, can be used, is during, for example, design and commissioning of different systems, along, of course, software development. If you're working on a robot, then it's amazing to have physically based photorealistic simulation. But when you're really designing and deploying your solution, ideally, you want to be able to do it with some degree of certainty before you're on site. A lot of times, we've had a personal experience, you go to the client side or you're preparing a deployment and there's only so much you can plan because maybe you have a 2D floor plan layout, maybe you have a video of how it looks like, maybe you don't have the opportunity to go there and really look at it with your own eyes. So one really interesting approach to this is to do this kind of design and implementation in simulation. So let's say, for example, I want to test out a robot and I want to see how a specific robotic stack behaves in an environment that I have not tested before. You all saw the robot that we were playing outside, the yellow robot dog, really, really cool. But you can't foresee how it's going to work in all situations. So if you can test how it's going to behave, not only robot dogs, but AMRs, in commissioning or in design, better. And this is the whole thought behind the modular robot integration project, that we create some kind of way that we can have the robotic backend, so let's call it the robot stack, connected to a simulator robot, and like proven, ISISIM is a good way to physically simulate robots, but then also use standards that are applicable in the industry to test out, for example, fleet management systems. Now let's talk about industrial manufacturing, intralogistics. Fleet management systems play a really big role there because you have maybe 100 robots that need to go from A to B to C, transport kilos, and do maybe like 1,000 orders a day. And you need to be able to commission this. And commission, I mean like pre-implement this before going to the client. Otherwise you're gonna, or before designing the factory or the logistics center or your warehouse or your shop, you wanna be able to see like, does this fleet manager make sense? Does this robot make sense? Like maybe you're thinking between two different robots and you wanna know, okay, does it make sense that I buy 10 robots that can transport 10 kilos, or do I buy 5 robots and each of them can transport half a ton? Like these kind of questions, if you test this out in simulation, can be solved before. And we did a presentation last year a bit on like optimization, how to optimize routes for this. But this year it's more focused on the integration. So you have the fleet management systems that manage these robots. And these fleet management, the agnostic ones, not vendor-specific ones, follow a norm called VDA 5050, which was a norm that was proposed by the Fraunhofer Institute in Germany, I think 2015, 17. I might not be right on the dates. But it's a norm that aims to standardize the communication between AMRs and fleet management systems. So in the end, it doesn't matter if you have like a mobile robot from one brand or the other, they all can use the same fleet manager, they all can use the same map. And they can all use the same connectors you've already implemented. So our goal here is we took like a really simple ROS stack that probably a lot of people that have used ROS know, which is nav2. We connected it to some simulated robots. In this case, we took a really basic robot that we designed and some other things. And then we connected it to a broker, with an MQTT broker that then transmitted the messages to the, to the fleet manager. One also really interesting thing we did here was we also wanted to test NVIDIA Metropolis. Metropolis is a solution or proposed solution from NVIDIA that allows you, and please Elias correct me because I know you know better than I do what Metropolis does, but does allow you to do real-time tracking of things. In this case, we did people through different cameras and then localizing them. And our first idea was why not try to feed the localization of these people into the fleet manager to then also give the fleet manager an opportunity to pre-plan routes based on active localization. And you can see here a really pretty architecture image. And I'm going to go now a bit more in depth. Sorry. A bit more in depth into the single components. And these are the 4 biggest components that we've looked into this project because, as said, we want to find out how to apply it and we want to learn how to use it. So NVIDIA Metropolis, we were detecting humans using live camera stream. So you can also simulate live camera streams in NVIDIA ISISIM. And then we streamed this video stream with VST to a Docker that was running Deep Stream PeopleNet, I think. And our idea was, okay, let's try to use this localization to enhance the capability of the FMS so that the FMS can actively maneuver the robots around the people before the robots see the people. So the robot doesn't need to be half a meter away that the fleet management system already pre-planned. And this is something we can test in simulation to see if it really works. The secondary component is the navigation stack. And Nav2 is one of the most, I would say, widely used open source navigation stacks. And we wanted to basically containerize it and make it that we can just create a dozen of different robots using the same navigation stack that would be applicable in the real world, so that we know that if this navigation stack is applied, that the same behaviors will happen in the real world with the robots because we're actively simulating everything. The third component is VDA. As said, we created basically a wrapper based on what Nvidia already provides, because they do have a VDA 5050 client that you can deploy and then connect to ROS2. What you then need to do is configure this client to your fleet management system. And we basically connected all the robots and then connected to state-of-the-art fleet managers that are available on the market to really test out and see if the management of the management part of the fleet manager worked in simulation. And matter of fact, it did. It worked pretty well, and it's really interesting to see how it can possibly help us commission. So the next time, if we're doing like we have to install 10 robots, if I happen to get access to the 3D model of the location, and I know a bit about what the robots are going to look like and how what their configuration is, like how much they can carry and everything, I can start designing a bit the map in simulation. And the dream is that one day we have so accurate simulations of the robots by itself and also of the locations that we can do all of this work offline, online, so to say, like remotely, and then we decrease the time that we need to be on site with the robots. And lastly, one of the biggest points we wanted to address in this project was infrastructure, because we want to standardize all of this. So we wanted to create this in a modular way, centered around Docker-esque components, and that was what you can see in the architecture is that we tried to have everything as individual modules that you can add or take out. And of course, following the standards of MQTT and VDA 5050 norm, so that we know that we're up to date with what the industry needs and wants. And yeah, I think that's it for the modular robotic integration part. Giving it back to Elias.
Okay. So the last one is a very interesting one for me, but it's also a very technical one. So I've been thinking about how to make this interesting for you. But it's super important for us, because when I joined, you have to think Accenture is doing these really large projects, right? So usually like multi-million, there's like really large projects with a lot of people involved. And one project that I worked in, for example, when I joined, was we built this factory of the future. So what we did is they wanted to build this new factory, and we advised them on what is the best robot to use. Do you use like a robot arm, or is it better or cheaper if a person does this job? You know, we had the chance to really build this up from the ground. And then, of course, we got input from the client. He was saying like, okay, we have these requirements, we cannot build this factory this way, and so on. And then always what they wanted to have at the end is, of course, a number. You know, they wanted to know how many AMRs or how many robots do I need to order, of which kind, how much are they going to cost, and how do we get this number? Well, there's a few ways to do it. There's like an expert guess, like we have these senior managers and they say it's going to be probably, they have experience with other projects and they know probably this is a good direction, but that's not good enough for a client, right? And so we have to give them a quantitative basis on how we get to this number. And how we do it is we simulate this upfront. So we really have this project or this the shop floor, we have it in the simulation, and then we say where is the robot going to go, how fast is the robot going to go, and then at the end there's probably, we put also some margin on top, because we say, you know, there are always things that you cannot really simulate. You know, there's always a gap between the simulation and reality, and so it's really bad when the production stops, so we better have a bit more so that the production will really run. The problem with these simulators is they simulate, right? And there's always a gap. And here is where Nvidia is coming in because they built a simulator which is much closer to reality. Because this simulator that we use, they basically animate what's happening. So you animate, you say the robot has this speed and it's going with this speed from A to B. And the way that Nvidia does it in their advanced digital twin is that you can connect the real robot controller. And then what we found is often that the robot behaves much differently than we expected. For example, sometimes the aisles are too small, and then the robot drives very slow, or we find that this particular robot stack really has a problem when it interacts with too many people, and then it takes much, much longer from going from A to B. And so there we found, having this makes a lot of sense, having this more advanced simulation, but it's much more difficult to set up, because you have to connect the robot controller, you have to connect all the joints. That almost takes as long as building this entire factory. I mean, it's of course less, but it is much more work than just animating quickly something. And what we tested, the hypothesis, is that the best of, usually like always, is to connect both worlds. You take the good things of the one simulator and combine it with the good things of the other simulator, and then you have the highest value. And that's what we show on the next slide here. So I brought a few pictures. With these traditional simulators, they have already this massive base of robots, for example. They have thousands of robots. I think this one has over 1,000 robots available just as click and drop. So you just select them in your drop-down, and then you can create a production line in maybe an hour, a full production line. So it really doesn't take much time, and they already move. And so in case we quickly want to show a concept, or we quickly want to visualize something for a client, or we want to get a first number, then this is really good to have. And then what we found is you can then export this to Isaac Sim, in this case, which is the more advanced simulator from Nvidia. And then, of course, you have to do much more setup, but then you also get much more accurate numbers on what you're going to need. And so evolving also, because this planning always evolves, right? Then we can already from the start give a number, but as closer as we go to the deployment, we can become even more accurate over time and always show what they can expect when it actually comes to reality. And we can do also, like we showed in the MRI project, we can do a lot of the setup already in the digital world. So even if we don't yet have access to the client side, we can already start the setup in the simulation. So that's where we are going. And you actually saw this as in one of the demo booths, because there we have one of our simulation. We tried to build a showcase in Munich in our innovation center. The robot didn't arrive, but we could already build this showcase in the simulation. And you can see it now with the Apple Vision Pro. And that's really the cool thing. And that's where we tried to combine these different simulators into one solution that's basically helping our clients. That's this project here. Then we have only one question open. Two. No. We have one question before we go to the questions. So, I mean, the topic of this talk is Nvidia robotics hype or reality. And what do we think? I think we showed a few use cases here, but I think this also depends on where you work and what's your angle on it, right? And so, Henrique, what would you say?
And I think it's, as you said, it depends a lot on your background. I think for robotics, there's a huge case to be made to use these technologies, independently if you're coming from a software development perspective. I don't know how many of you have done software development with, for example, ROS. Up until a couple of years ago, you were basically restricted to Gazebo, maybe Mujoko, a little bit of here and there, but you never had really big access to these kinds of platforms. And I think Isaac Sim comes to fill a hole where it makes it easier to do simulations with out-of-box components. But then also in the digital twin space, I think, as I said, commissioning, even sales, you can use such platforms to really show the value of what you're trying to propose. So I think it's fitting to the hype that it's getting, because it's a reality that we're going to come closer and closer.
Yeah.
And you?
That's the system and platform. So Henrique internally is taking care of system and platforms. I take care of simulation. And from the simulation space, it's also hard to differentiate. We showed today, there is a lot of value there. But I think a lot of value is still to be materialized. So right now it's a lot of concepts where we still also have to actively create connectors and so on. But I think if you're a young person, it's a super interesting space to work in. I think there's extremely much opportunity, even though maybe not everything that's happening right now is how it's going to be in the future. But I think the direction, I think, is already quite promising where we move. And with that, maybe over to the questions that we have. If you have other questions, feel free to also drop, and then we can answer them. Okay, so we don't have any upvotes, so they all have the same level. Isn't Tesla actually moving away from Nvidia and developing their own hardware? Yeah, or are other companies moving into the direction of Nvidia? So it's a lot of. I mean, we are not Nvidia spokespersons, so we don't have any. Cannot say anything on this. I don't know the Tesla stack. Maybe Henrique, you know.
No.
Exactly. So I cannot answer that question. But yeah, we see a lot of accelerated compute there, but that I cannot answer.
So for this one, I would like to ask the question, because we've already answered, what is your opinion? Can the people that think it's a hype, or the other way around, who thinks it's a reality that these kinds of tools and platforms will bring and will follow to be standards in the future in this room after what we said? Okay, that's already pretty good. Who didn't have an opinion by the beginning of this session and doesn't have an opinion right now? Just interesting. Next time we need to do better. We're trying to inform. But that's nice to hear.
Okay, then can you use Omniverse to train for unique use cases or train robots for more wider tasks? Yeah. That's a very interesting one.
There's really interesting public things that you can find online on how they use Omniverse to train. And I think it's still called Isaac Gym, or maybe they changed the name, which is the reinforcement learning, let's call it GYM. And one really known example of it, I think it's also publicly from Nvidia, is Anybotics. They even have a couple of videos. Anybotics is also a company that does quadrupeds, and they trained their reinforcement learning model, or part of it, in Isaac Gyms or in simulation. And that's really specific, of course. We're talking about walking. More generalized tasks, maybe, I don't know, Elias?
Yeah, so in the beginning when we talked about AI, we talked about level 2 and level 1, right? And maybe differentiating here also in level 1. So level 1 we already see, like you can do a lot of edge cases. If you want to train your computer vision model on a defect, we don't have much data on the defect, and then you can create this synthetically. So this is already something we actively do for a wide range of clients. So for level 1, we already see a lot of value there. For level 2, I think, so there are these scaling laws, right? That with larger amounts of data, larger amounts of good data, of course, your AI significantly improves. That's what they have with OpenAI, right? When they had the larger training base, also the AI got significantly better. And so right now it's academic that they believe, because it's really tough to generate this data, that it could be possible to do this in simulation, but it's not yet proven because there's always the sim to real gap. And so at this stage we cannot, there is a lot of people that bet on that, but at this stage I think it's not yet clear what's going to be the reality. But it's very promising that that is actually the case.
Then if simulations is good at reality, wouldn't this mean we are living in simulation? This question has two parts. So as Elias said, like the sim to real gap still exists. So not as good as reality, I would say, by now. And are we living in a simulation? That's a philosophical question. And we're in the electrical engineering university faculty, so that's another discussion.
Yeah, but you can ask Henrique afterwards. I'm sure he has an opinion.
But yeah, have you seen The Matrix? Yeah. And then, can you use Omniverse to train for a unique use case? No, that one.
This one we already answered. I think we are through with the questions.
If you have any more fun questions, feel free to ask, or ask us also after the presentation is done.
Exactly. Cool. Then handing over to the organizers, I guess.
Perfect. Thank you for attending.